Hi, it's Ted Ritzer, host of the Greening Government Webinar Speaker Series. The series is a collaboration between my department, Alberta Environment and Parks, the Alberta Climate Change Office, and the Municipal Climate Change Action Centre. The goals of the speaker series are to help governments in Alberta grow their green economies and also to help them reduce their carbon footprint. Now, the theme of the webinars today is really looking at whether we can, within Alberta, create a blockchain-powered green economy. And today, we're joined by Dr. Phil Windley, who is the chairman of Sovrin, which is really responsible for a decentralized digital identity. But in looking at Phil's CV, he's got a heck of a lot of experience within IT. He's a former chief information officer for the state of Utah. He looks like you were sort of a founding e-commerce developer, Phil, in terms of looking at developing technology to empower both, e-commerce at sort of the state level within Utah, but also at a national level within Excite, which I thought was kind of acquired by AOL, but maybe my memory is wrong. But we're so fortunate to have you present today, Phil, on, what the heck is this sovereign and blockchain-based digital identity, and how could it serve governments within Alberta?
Yeah, thanks, Ted. It's great to be here. Appreciate the opportunity. Excuse me. So I'm going to talk today about a concept called self-sovereign identity. And I welcome your questions and comments as we go along. Sovereign is a global public decentralized identity network. There is a foundation behind it called Sovrin Foundation. I'm the chair of that. I'm also an enterprise architect in the office of the CIO at BYU, and have been involved in the identity space for some time. What I want to talk about today is the relationship between self-sovereign identity and trust. I don't think it's unfair to say that internet identity is broken. There are a lot of anti-patterns, there are a lot of privacy breaches, and more importantly, I think identity transactions cost too much, and further, they're too inflexible to support many of the use cases that we envision, both in business, in government, and as individuals. So I'm going to try and explain why I think a decentralized identity utility is a better way of using identity to create trust than the systems that we've built to date. So that's a pretty tall order, and I hope that by the time we're done, you'll think that I have succeeded. So this cartoon is the most reproduced New Yorker cartoon ever, first published in 1993, so almost 25 years ago now. And while funny, it remains painfully true even today. I'm the founder of something called the Internet Identity Workshop, and we adopted this idea, this concept of the dog on the internet as kind of our theme. And so this is our logo. We've been doing this now for 13 years. We do it semi-annually. We just completed the 25th meeting of IIW a couple months ago. We'll be meeting again in April, and it's been fascinating to watch that journey. Despite a quarter century of advances in internet technology, if you look at this idea of on the internet, no one knows you're a dog, while that's still true, it's also true that there's not an easy way to prove that you're human or that you're over 18 or that you live in a certain address or graduated from a certain school or work in a specific company or own a specific asset. These kind of assertions are known in the digital identity industry as claims, because someone is claiming that this assertion is true. They're difficult to trust online because they're hard to verify. If you think about an identity system, this example is Google. I'm sure most of you will recognize it. Why do we do that? Why do we build an identity system? And while you could come up with a lot of reasons, I think the primary reason is trust. When we're authenticating someone, we're establishing trust. In this case, we're trying to answer the question, how can I trust that the person at the other end of this connection is the person who originally signed up for this account? Trust is something that is ever evolving. It used to be very local, based on the people you knew, your neighbors, the local merchants, that sort of thing. As people started interacting more and more with larger groups of people, they had to find ways to trust strangers. And a lot of the institutions that we have in the world today are based on trying to extend trust beyond this local sphere. And so this idea of institutional trust, governments, banks, educational institutions, are all in one way or another an intermediary that tries to extend trust beyond the local sphere. Intermediaries cost money, they take time, as we've seen. They sometimes even threaten individual privacy and security. Now, the reason why trust online is difficult is because the identifiers that we use lack context. They don't have the clues that we would use in a face-to-face interaction to determine whether or not something is true. And the best way to create trust, create context for an identifier, is to link it with other information in a way that we can verify. We call systems that place identifiers in context trust frameworks. Now, the most obvious examples of trust frameworks are things like the authentication systems that we're all familiar with. When a site like Amazon builds an identity system, they're creating a trust framework. So simple trust frameworks like Amazon's allow Amazon to know things about the people who are coming to their website with some level of certainty. In this case, the trust framework is centralized, it's owned, and it's private. We call these administrative identity systems because they're designed to administer identity and establish trust for a specific domain, and usually by a specific organization, Amazon in this case. The system, the identifiers, and how they work are all owned and controlled by Amazon, and they're subject to Amazon's terms and conditions. I have a friend who lost his Amazon account, and it was surprisingly difficult for him to get it back. Amazon has no, they don't owe you an account. They get to choose who gets accounts and not. We often think of these things as our online identity, but in fact, they're not ours. They belong to somebody else. Now, more complicated trust frameworks involve federation, and one that we're all quite familiar with is the credit card, like Visa or MasterCard, those networks. If you think about using your credit card, it's actually a minor miracle that you can walk into a merchant in London, say, and hand them a credit card from Utah or Alberta, and they take it and they're perfectly satisfied that at the end of the day they'll have money in their account. And the reason this works is because there's a complicated system of linkages between you and your bank and Visa, Visa and the seller's bank, and the seller and their bank. And these linkages are legal, business process, and technical. We call that the BLT sandwich of a trust framework, the business, legal, and technical agreements that everybody has. And these kind of trust frameworks are not unusual either. There's a lot of federation that happens, but they're complicated to set up, and they cost, they take a lot of time and a lot of money and a lot of agreement between people. Now, in the physical world, trust works somewhat differently. If you think about walking into a pharmacy to pick up a prescription, and they need to know, for example, that you're over 18. typically, one way that we would prove that we're over 18 is to provide a driver's license. Now, if you think about that, a driver's license is not a credential that was designed for proving that people are over 18, or proving that people have the legal right to get a prescription, or any of the other hundreds of use cases that driver's licenses have. They're designed for a specific domain, that is licensing drivers. But because of its implementation, it has uses outside the administrative domain for which it was designed. So the driver's license functions as a decentralized, trustworthy credential that serves as a container for a specific set of attributes. And its veracity can easily be checked by recipients. And these are the important properties that allow it to work. We usually see the state as a trustworthy party for establishing that someone is a certain age. And driver's licenses are difficult enough to forge that most of us believe that they haven't been tampered with. And these are the kinds of properties that we want in a decentralized identity system. So let's talk about something called a verifiable claim. I mentioned earlier that these attributes are called claims in the identity industry. And if we can verify them, then we have something that looks somewhat like a driver's license. So let's say that my employer, BYU, gives me a credential that says that I work for BYU. And later on, I can transmit that credential to, say, a bank who wants to know that I'm employed, and they can prove that, or they can be satisfied, rather, that the credential hasn't been tampered with, and that BYU really issued it, and they really issued it to me. And they can do this without any kind of integration between the bank and BYU. This is how we typically do things online today, and it's the cause of a lot of frustration and cost. So these kind of claims, a verifiable claim, if we could do this digitally, could be used in ad hoc situations, just like we use the driver's license in ad hoc situations. Rather than having to have business relationships or legal agreements and technical integrations, we could rely on the credential holder to be the conveyor of the trustworthy claim. And these things, like I said, are called verifiable claims. There's actually a W3C working group that's standardizing how these things work. And they're the heart of a decentralized identity system that functions in the same way that the offline world does. This is a trust triangle that has important properties. The first important property is that there's no central authority for all of the claims. So in other words, nobody is deciding that there is a driver's license claim. No central authority is deciding that. Anybody could decide that they're going to issue a claim for any specific purpose. The second important property it has is, as we mentioned, there's no link between what we call the claim issuer and the claim verifier. The claim verifier can guarantee or can be satisfied that the claim is valid without any kind of communication to the claim issuer. The third important property is that verifiers make their own trust decisions about what credentials they're going to accept. Think about the earlier example of the pharmacy. They can decide they want to accept a driver's license. They could also say that they're going to accept other kinds of identification that they trust. Nobody tells them that they have to accept certain kinds of credentials in order to satisfy themselves about the specific claim that they're interested in. And the fourth property is that owners are free to choose what claims they carry. All of us have wallets or purses that we carry claims around in every day, and nobody tells us we have to carry certain ones. Now, of course, when we're conducting certain activities, we know that we have to have a driver's license on us to drive, but for the most part, we fill our wallets and purses with the kinds of credentials that we think are the most interesting to us. So there are three things that make this all work. The first is a distributed ledger or a blockchain. And the reason why a distributed ledger is important to a self-sovereign identity system is because one of the biggest problems with building identity systems in the past is discovery. If I give you an identifier, you need to be able to look it up somewhere and see what that identifier means. And in the past, the way we've solved that problem is by creating centralized registries, centralized repositories of information that people could go and look things up on. Distributed ledger allows us to do that in a decentralized way. And because it's decentralized, we can create something that's global and public. And it has three properties that align very well with the properties of the internet. Nobody owns it, everybody can use it, and anybody can improve it. The second important feature or component of a self-sovereign identity system is something called a decentralized identifier. So these decentralized identifiers allow us to, they're cheap and they're persistent. Cheap allows us to create one for every relationship that someone has, and persistent means that they won't get reused and confused, that nobody can take them away. These decentralized identifiers can be linked via the distributed ledger to something called a DID description, which contains the public keys and endpoints that are important for that identifier. So when you look up the identifier on the blockchain, what you get back are the important pieces of information you need in order to be able to use that identifier. And the third important piece is what we just talked about, this idea of verifiable claims. Verifiable claims provide the means for third parties to provide information owners with credentials. So rather than this system supporting the idea that we've come to know as an identity provider, someone who is the centralized authority for all of the known attributes of a given subject, this allows for a very decentralized system where anybody can use it and they can collect as many credentials from as many third parties as they need in order to carry on whatever business is important for them. I want to talk for a minute about this idea of sovereignty. When you say sovereign, sometimes people get nervous because we naturally associate that with the idea of statehood. We talk about sovereign states, for example, and there's a relationship there, but it's not necessarily the one that everybody thinks about. Sovereignty came into being as a concept in 1648 when a number of principalities got together and signed what were called the Treaties of Westphalia that ended several decades-long religious wars. These treaties not only ended the wars, but they established our modern idea of state sovereignty and non-interference. And that idea of non-interference gives states exclusive control over the areas within their borders and establishes an incursion from another state within those borders as an act of war, right? So outside of those borders, states have to act, they relate to other states as peers. And that's really the key idea when we talk about self-sovereign identity, is that it's not about total control, it's about boundaries or borders that sustain a balance of power that leads to negotiation about the nature of the relationships between the various entities in the system. So sovereign clearly defines boundaries within which a person has complete control and outside of which they have to interact with other people and institutions with shared information. So sovereign is designed to give identity owners independent control of their personal data and relationships. And it's also built so that people are structurally part of the transactions made about their identity. One of the important reasons why we create pairwise identifiers is privacy, and I'll talk about that in just a minute. But it also prevents third parties from transacting without the identity owner being part of the equation. And so a self-sovereign identity system structurally puts people in as parties to any transaction that involves their identity information. Let's talk for a minute about privacy, because I think that privacy is one of the key features of a self-sovereign identity system. If you think about sovereignty, meaning that you are in control of how identity information about you is used, then without privacy, you can't really have control. And so I think it's a must-have feature for an identity utility. And there are several ways that privacy is baked into the sovereign architecture. The first, as we talked about, is that identifiers are pairwise unique and pseudonymous. That prevents correlation. One of the greatest risks to privacy and security in today's internet is the fact that we rely on universal identifiers like email addresses and cell phone numbers, and even in many cases, national identity numbers, such as the Social Security number in the United States. And as long as we rely on globally unique universal identifiers, we have a big problem with correlation. I believe that universal identifiers are a 20th century solution to 20th century problems that don't have any place in the 21st century digital economy. There are just too many problems with them. So as we talked about, DIDs are cheap, and so you can create as many as you want, which allows us to create a different DID for every relationship. The second key idea of the architecture is that personal data is never written to the ledger. If you look at many of the blockchain-based identity systems, you'll find that a lot of them write personally identifying information to the ledger. And sometimes and often it's encrypted or even hashed. And we don't believe that even that is enough. I think if anything that we have learned about cryptography over the last several decades is that any encrypted piece of information has a shelf life, and that eventually it will be decrypted because computers get more powerful. And so it's not safe to write encrypted information to a public ledger. And hashed information is similar. Hashing provides a way of creating correlation, which is another problem for privacy. The third, so let's talk about what is written to the ledger. So DIDs are written to the ledger, and they don't have any personally identifying information. Things like claim schema and claim definitions are written to the ledger. Again, there's no personally identifying information. And finally, the ledger is used for revocation, which is another really important concept in an identity system. If I'm going to issue a driver's license to someone, for example, digitally, I want to be able to also revoke it so that when it's taken away, it's no longer useful. The third architectural feature that supports privacy is something called a zero knowledge proof, which is a little bit of well, it's a name that gives people pause, because how can you prove something in zero knowledge? But it's actually true in the sense, because what happens is, let's say I have a driver's license and it has a number of attributes on it. If I walk up to the bouncer at a bar and provide them with my driver's license to prove that I'm old enough to get in, it's unlike, we don't expect the bouncer to be able to memorize it and take all the information down and then correlate it later. But with digital systems, of course, all of that is perfectly plausible. All we really need to prove is that we're over 8 or over 21, or whatever the drinking age is, wherever you happen to be. And so a zero knowledge proof allows you to prove things about the identity attributes without actually revealing the identity attributes themselves. So rather than having to reveal the birthday, or even worse, all of the information under a driver's license, you can just prove that this credential proves that you're of the right age. Another feature of zero-knowledge proofs is that they link these identifiers. So if you think about a verifiable claim, if my employer supplies me with a verifiable claim using the identifier they have for me, and I provide it to you, there's not a good way for you to know that that's about me, because you and I have a different identifier. And so the zero-knowledge proof is a way of linking those identifiers as well without revealing them, so that we can know that we have that this claim is about the right person. So all of this self-sovereign identity system represents a universal trust framework, something that is flexible enough and decentralized enough to be used by anyone without everybody having to build it for themselves. That's one of the things I think is the most important about this idea, is that just like the internet gave us the ability to communicate with other people at a distance universally without anybody having to build the whole thing themselves, a self-sovereign identity system, global public decentralized identity utility, gives us the same thing. What Sovrin does is it provides accessible provenance for trust transactions. You can use that provenance for accountability, and that is ultimately the foundation for trust, is that idea of accountability, and Sovrin provides that universal system for doing that. One thing I always like to talk about is the idea of consent. One of the things that is on a lot of people's mind in the identity community right now, especially as we move towards May 2018, is the GDPR, the General Data Protection Regulation that the EU has put in place. One of the carve-outs or safe harbors in GDPR is the idea of consent, that if you have consent to use information, then you protect yourself from a lot of the liability. And there are obviously quite a few specifics around how you get and record consent and what it means. One of the things that Sovrin does is it provides, by default, standard mechanisms for recording consent, both how the information will be used and what was shared. And that's a really important property for protecting companies from liability and people from the misuse of their data. I wanted to finish off by talking about some of the ways that trustworthy claims can change what we do online. One of the most obvious ones is username and password. You'll see a lot of things, I think, over the next few years that blockchain identity systems are doing away with usernames and passwords. I don't think there's anybody who's going to cry a tear, except maybe some of the companies that make a lot of money selling these systems, over the demise of the username and password regime that we have lived with for the last couple of decades. There's a lot of applications in healthcare. We have a partner called DoctorsLink that's testing Sovrin in the UK as a way of exchanging verifiable claims about healthcare professional certification. It turns out that in the UK, they use a lot of temporary healthcare professionals, and the estimate is that they lose about 5 days of professional work per year in the credentialing and credential proving process. And so DoctorsLink is very interested in seeing if they can reduce that, and we believe they can. I work at an educational institution. There are a number of interesting use cases in education. We're conducting a proof of concept that gives students control over their personal information and allows them to share it with others. This is important to us because we're trying to link a number of otherwise non-integrated university systems, both in and outside the institution, into a single whole, and using the student as a conduit for this kind of information and doing it in a way that's trustworthy allows us to do that more flexibly and with a lot less cost. One of the big features of self-sovereign identity systems is that they give us hope that we can solve the problem of identity for a number of disadvantaged populations. The UN estimates that there are over 1 billion people in the world who are underdocumented and that suffer because of this. There are the obvious ones of refugees, but there are a lot of others some who just never even have a government ID from the start. We have a partner called iRespond who's conducting a proof of concept to show how sovereign trustworthy claims can be used with their biometric identification system to record immunization and other health data for underdocumented people in Africa and Asia. One of the strong and early partners of Sovrin was the financial services industry, credit unions, banks, and others. I don't think anybody would think it was a secret that banks are pretty awful at building identity systems. Part of that is just because they have a lot of really, they're very regulated, and so that limits what they can do. The know your customer KYC demands on banks are pretty heavy, and they're working to use these kinds of claims in a self-sovereign identity system to reduce that cost and to make it more flexible, more online, less in-person kinds of interactions. And finally, I just wanted to mention in the government sector, we have a number of partners and pilots that we're working on with governments. Governments have long been seen as the kind of the foundation of identity registration, especially for legal identities, obviously. The state of Illinois has what they call the blockchain initiative, and they recently announced that they were going to start writing birth registrations to the sovereign ledger as a way of creating a digital birth certificate. The government of British Columbia has a pilot right now where they're using this to register businesses and be able to provide claims to businesses that they can use, that they're verified or that they're legally registered legal entities in the province. And we're still early, but we're working with some people in Utah and Arizona to see how we could use sovereign claims for a driver's license that was digital and online. There's a number of government areas, and I think the list is large. When I got done being the CIO for Utah, I wrote a book on digital identity, and some people thought that was a little strange that I was no longer the CIO, but the first thing I did was write something about identity. But it turns out that the book was filled with examples from the state where identity had some, where we'd used identity in the state and how it was playing into what we were doing. That was actually one of the places I learned the most about identity. So I don't think it's a secret that there's a lot of identity that can happen inside governments. So let me tell you what the status is right now. Excuse me. Sovrin has launched what we call the Provisional Network. There are about 24 validators or stewards, we call them, on the network. These are the nodes that actually write to the ledger. One of those is ATB Bank in Alberta, and we have a couple of other recruits that we're working with in Canada. I can't talk about right now publicly, but we're seeing some interest there. These are organizations from around the world, some large, some small. The sovereign.org website actually has a list of the stewards who are currently operating. The Provisional Network, it's called Provisional because it has reduced features, but is operating the production ledger and is achieving consensus using the ledger, and allows people and institutions to begin working with the Sovrin Network and figuring out how it works and building some pilots. We believe that with a full-featured general availability network will be sometime in the spring, and that's when we'll be launching and actually signing up, people as members of Sovrin, or as, sorry, not as members of Sovrin, but as users of Sovrin, and that'll largely happen through third-party partners. Right? A lot of people won't ever even know that you're using Sovrin, at least at first. It'll be kind of like when the web rolled out and somebody just said, oh, you got to download this thing called Netscape and then type this in, and you didn't really know what you were doing, but the light bulb went on when you saw the second place you could use it. So the conclusion, I think that trustworthy claims are a major shift in how we use identity online. Rather than just being about centralized repositories of a few attributes that are interesting to whoever is administering the identity system. Sovrin provides a way to create a decentralized, flexible identity system that can be used by anyone for any identity transaction that they need. In 1990, hardly anyone could have conceived of a universal communications medium, and the internet transformed our world. And I think a universal system for exchanging trustworthy claims promises to do the same. So that's kind of the end of my my spiel. I'm happy to answer questions or have a general discussion, whatever is interesting and useful.
Well, folks, you can pose questions within the online Q&A window. And while you're thinking about questions, Phil, I would just pose this, at least my understanding of the Equifax data breach seems to illustrate very well your whole point about essentially, 20th century thinking existing in the 21st century. And from what I've read about it, there's an estimated 143 million Americans could be facing a serious threat of identity theft, and that the hackers seized names, social security numbers, birth dates, addresses, and even some driver's license information. What kind of things could you comment about the Equifax data breach?
Well, I think you're exactly right. I mean, that is an example of how, our 20th century thinking has led us into dangerous territory. I mentioned that banks have been early and vocal proponents of what we're doing. And one of the reasons is because if you think about when you call up your bank, every question they ask you to establish who you are is likely something that was in Equifax. And so, they really just lost their ability to validate customers over the phone, and that's a huge problem for them. So I think Equifax, I hate that it happened, but it certainly highlights the need for a system like we're talking about.
Well, the other thing, Phil, that I'll comment while we wait for folks to pose some questions is there's a December 6th press release or article by U.S. Senator Maggie Hassan, and what she said in the CNET article is, we need to listen to tech companies to be sure about how we go about doing this as far as security so that they can continue to innovate, but it's our job to make them aware, as well as consumers, that we really do have threats we have to address. That's something the public sector should be doing in partnership with the public sector, listening to the public's concerns. What do you think of that contention?
So I think it's true. I mean, I think there's, like anybody, I worry about, laws that write prescriptions too inflexibly and then tie your hands, essentially lock you into a system that you don't want to be locked into or shouldn't be locked into. But I do think that the GDPR, is probably the most forceful, the law with the most teeth in terms of protecting users' privacy, and it's changing how companies think. You can't go to an identity conference this year without having the major focus of the discussion being about how people are changing what they're doing because of GDPR. So it's clear that governments do have a big role to play. they're the ones who are going to make people pay attention.
Well, I guess another comment that I'd pose is I read a comment about, no one would trust their healthcare records to Facebook or Google. But further to that, Phil, is like the whole idea of whether it's Google, Facebook, and Twitter, the whole idea of their business model is predicated on selling personal data to basically the highest bidder. And I think that's a real issue for people. And I think that presentation by Yogi about what's being done in Finland and the EU, we got to grapple with this.
Yeah, I think you're right. There's people call these companies different things. One I've heard is GAFA, right? Google, Apple, Facebook, Amazon. The kind of the big companies who have so much of our personal data. And for most of them, right, I think, Apple is perhaps, Apple and Amazon are a little different because they're not necessarily in the business of selling your data. In fact, I think Apple's using that as kind of a point about why you should trust them more. But it is true that, Facebook and Google, they don't really have a business if they're not selling personal data. And, I expect they're not going to be friends or friendly to, systems that necessarily put people in charge. But, I think that's the way the world is going, that more and more people are being concerned about this. I used to say that privacy didn't sell, that it wasn't a feature that you could sell on. It might be a point that people would go, oh, that's nice. But I'm thinking more and more that people are looking for privacy as a feature in the things that they use, the services they use.
Well, I guess I'll give folks sort of a last call for any questions. But Phil, what kind of words of wisdom would you like to provide governments in Alberta about considering, blockchain in general, but maybe more specifically Sovrin?
Yeah, so I think blockchain in general, I'm sure that there are a number of agencies in Alberta, there certainly are in Utah, who are looking at how will blockchain impact what we're doing? How can we use blockchain differently? I mentioned the BC government and the folks over there. And by the way, if any of you would like an introduction to those folks and what they're doing, I'm happy to provide it. You may have your own, but I can point you directly at them. In business registration, just almost every place where governments are keeping track of something. And blockchain provides us with a way of doing that in a more decentralized manner that may or may not be appropriate in some cases, but in many cases it is. You ask about Sovrin in particular. I don't think it's necessarily decentralization that has led Illinois or to consider birth registrations in Sovrin, or BC to consider business registrations in Sovrin. It's more about the flexibility and the independence that it provides. If you think about how birth registration works, we give people birth certificates, and we pretty much rely on them conveying those birth certificates as a means of proving where and when they were born. And that system is by no means perfect, but it has one that we've used for a number of years. And just the ability to do that online, right? To have a digital birth certificate that I could take to a bank as part of their KYC process and that they could trust was real, is an incredibly flexible and removes a lot of friction from a system that otherwise is becoming really hard. I think we all have an interest. I'm going down a little bit of a rabbit hole with KYC, but we all have an interest in making sure that banks are only giving accounts to, real people, that they're not terrorists, that they're not doing money laundering, all of these things that the regulation is meant to keep from happening. And we would also like to make sure that that has the least impact on regular folks as possible. And being able to have a flexible credentialing system like the one that Verifiable Claims presents allows both of those goals to be met. And so that's, I think, one real reason why governments ought to be interested. It's just because it achieves their goals with less impact on society. And I know that from being in government, that's always a consideration.
Well, I guess sort of the last point that I'll make, and just a question to confirm whether I'm accurate in my understanding of Sovrin. Phil, is Sovrin open sourced, meaning that any government on the planet could access and use and collaborate with you guys?
Yeah, it is. So Sovrin, I mentioned the Sovrin Foundation. Sovrin Foundation holds the IP and is the director of the open source project. But there is the open source code is at Hyperledger. Hyperledger is a part of the Linux Foundation and was put together to host blockchain projects. And at Hyperledger, it's called Project Indy. So if you go to Hyperledger and you look at Project Indy, that is Sovrin. And what we do is we take the Indy code. We're obviously managing the development of it, but when we're deploying the network, when we take that code, we package it up, and that's what the stewards run, is that open source code.
Well, this has been a fantastic presentation, Phil, and I'm pretty sure that you'll be approached from some folks who want to collaborate, if not Alberta, other jurisdictions in the world, because we're posting this presentation to our YouTube channel. Anyone can find the presentation by searching for MCCAC. And again, Phil, thanks so much for doing this presentation.
Thank you. I was happy to be here.
Excellent. Thanks. Bye now.
Bye.